Hey everyone, welcome to Serving for the Win. I'm Dave, and this is my nightly build. If you're like me, you've had a certain question on your mind lately, and that question is, where does Dave store all his video files? No? Just me? Well, hopefully I can make the answer interesting even if you don't have terabytes of files to back up. If you've been a fan of the channel for a while now, you know that I've got an archive of over 1,000 videos that I've published on this channel alone, and I keep every single one of them. I also have other YouTube channels where I publish in 4K, and that adds even more. Now, I could handle this like a rational adult, maybe by deleting my videos after I post, or maybe just keeping the raw and the project files without the publishing ones. But what if there was another way? Enter the Beast, a 120 terabyte file server that I put together last year. Plenty of storage to keep the nightmare of running out at bay for at least a few years anyway. Problem solved, right? Well, not so fast. You know, there's a guideline in data security that you should have 3 independent copies of your data on 2 different types of media, with one of them being kept off-site. Now, there's a couple of possibilities, especially if you want to stick to the 2 different media guideline, but I settled on magnetic tape. If you're under the age of 40 and you're not involved in IT, then you might be surprised to hear that even come up as an option. But it turns out that magnetic tape is still in active development as a viable enterprise solution, and it has a few properties that make it very well suited for my particular application. Magnetic tapes are easy to store off-site, being environmentally stable and requiring no electricity to maintain. They're also easily scalable. If I wanted to add more capacity to my server, well, it wouldn't be as simple as just buying more hard drives. I already filled up all the slots, so I would need a new chassis, or at the very least a new SAS card, to be able to plug more HDDs in. In contrast, if I want to expand my tape storage, it really is as simple as buying more tapes. Now, there's already a storage solution that has all these properties, and it's a little bit better known than tapes. I'm talking, of course, about optical media, including CDs, DVDs, and Blu-rays. There's a couple of reasons why I chose tape over the optical media as a solution, even though I already had a laser drive that could read and write the data. Well, the first is capacity. The biggest commercially available Blu-ray disc is 128 gigs, and I have individual files that are larger than that, which means I would need to split the file into multiple parts in order to store it on optical media. Now, there's also a lot of files in the 40 to 60 gig range, which would require either buying lots of extra disks to store the files inefficiently, or being very careful and backing up the files in a difficult to follow system to fill each disk mostly to capacity, which has its own problems related to record keeping and increased complexity. This low capacity would also require a larger number of disks. Let's assume that my data hoard is 10 terabytes as an example. It would take about 80 128 gig disks to store it all, and that's if each one is filled to capacity, which, like I noted earlier, is probably not realistic. The space required to physically store that many disks isn't that bad, but the organization required to keep track of which disk the file that you want is on, well, that's a little bit more difficult of a problem. And then there's the problem of writing them. It takes about half an hour to fill a 128 gig disk, and that's assuming you're writing at 16x, the fastest supported data rate the whole time, which, spoiler alert, you probably won't be. In contrast, the tapes that I bought can hold about 2 terabytes of data each. I used about 12 tapes to fit my entire data hoard, and that was being rather wasteful with some of the tapes in the name of easier organization. Although the write speeds I saw were somewhat worse than what I mentioned with the optical media, starting a write job before you go to bed or leave for work and coming back to it being done is a lot easier than having to change out a disk every half hour. Now, the other major benefit of tapes is cost. Now, the best price that I could find on 128 gig Blu-ray discs was between $10 and $15 each, which incidentally is comparable to what you can get one LTO 6 tape for secondhand online. And the tapes hold about 15 times as much data. Now, while there are some great reasons to use magnetic tape for your data setup, there's a couple of points against them, and the biggest one is also cost. While the per tape expansion costs are relatively low once you get a system set up, the capital cost of doing that is rather off-putting. You can definitely save a bunch of money if you buy secondhand equipment, but the cost is still there. It's just a matter of whether you're paying with dollars or sanity. Tape is also a bit finickier to set up than an optical solution. While you can probably buy a Blu-ray drive that can read and write discs and expect a simple plug-and-play experience, the same cannot be said for tape drives, which will require some specialized hardware to connect with your computer and some specialized software to get them functioning. More on the details later. Okay, so you decided that you want to try tape storage. What do you need? Well, the first, biggest, and most important part of your setup is a tape drive. Because of the high cost of a new drive, you're probably going to want to get one secondhand. Now, this means a big part of what you get is just going to come down to what's available. So when you're shopping for a drive, you want to know a little bit about the different types. And there are several different standards of magnetic tape-based media storage that have been introduced over the years. The one that you want to get is called Linear Tape Open, or LTO. As of the production of this video, there have been 9 generations of this standard, labeled LTO 1 through 9, with LTO 10 just starting to come out to market. The primary difference between the generations is the amount of data that can fit on each tape, with the capacity close to doubling each generation. For reasons that I'll talk about later, I would not recommend any generation before LTO 5, and for cost reasons, the most recent couple of generations are probably out of consideration too. I bought an LTO 6 drive, and I think that strikes a pretty good balance between drive cost and tape capacity, but I also happened upon a really cheap price for this specific drive on eBay, so if you find a good deal on something else, go for it. There are a couple more things that you might want to check before you buy a drive. Can you tell the difference between these 2 tape drives? And the answer is that one of them is made by IBM and the other is made by Hewlett-Packard. And yes, that is a big difference. Most of these drives that you see sold secondhand come from a machine called a tape library, which has one or more drives installed in it. The HPE drives that are installed in tape libraries ship with firmware that allows them to be used in standalone mode, which is what I'm going to be doing. The IBM drives are not like this. You can only use library drives in libraries unless you manage to update the firmware. Now, I've come across some accounts of people who were able to connect to an IBM drive via RS-422 and use serial commands to update to the standalone firmware. I have no doubt I would have been able to do that, but I solved the problem in a different way by returning the first drive that I bought and buying an HPE one. Most tape drives were manufactured by one of those 2 companies, and there's also a third company called Quantum, which I don't have any experience with, so let me know in the comments if those drives have the same issue. Drives from other companies, such as Spectra or Magstor, are generally manufactured by one of those 3 that I mentioned and badged with the other company's logo on them. The last main difference between drives is how they connect to your computer. There's 2 main types, SAS and fiber channel. I guess technically there are drives that connect via USB, but not in my price range there weren't. The operation of the drive is exactly the same. The only difference is how you connect it to your computer. Now, I'm assuming your computer that you want to use probably does not have a SAS port or a fiber channel port, and to add one, you'll need to buy a PCIe expansion card. Unfortunately, this means tape drives are a desktop-only thing. It is possible to get a tape drive running on a laptop, but of course it would require some extra hoop jumping, and it might not be particularly practical. Fiber channel drives seem to be somewhat cheaper than SAS drives in my experience, and so that's what I ended up with. And that's a good thing because the PCIe cards and the cables that you need for that type also seems to be cheaper. Here's the fiber channel PCIe card I'm using. It has 2 ports, but you only need 1. These are readily available secondhand. I saw a bunch in the $5 to $20 price range when I was shopping for them. Don't worry if it's ancient, so are the tape drives, so that makes sense. Make sure you do get a PCIe one, not PCI or PCIX. There's a difference. If your computer was made after 2004, it's probably going to need PCIe. PCIe 2.0, which is what a lot of the cards were when I was shopping for them, that's fine. Even if your computer has a motherboard with PCIe 5.0 slots, it's backwards compatible. There are a couple of other things you need to be careful of, though. First off, you need to know whether to buy a card with a full height or half height bracket. Many of these cards were used on servers that had a 1U or 2U form factor, which used the half height bracket, which is a shame because most computers that you would probably be using it with require a full height bracket. The other thing is to make sure you buy a fiber channel with the SFP modules included. I would not recommend buying them separately because modules from different manufacturers apparently are not compatible with one another. If you're getting a SAS drive, I don't have a lot of experience buying those, but in my description, you can find a link to Art of Server's channel where you can find some helpful videos on the topic of picking out a SAS card and a SAS cable. And that brings us to the next piece of hardware that you're going to need, a cable to connect your tape drive to your computer. For fiber channel units, you're going to need something like this. You only need 1 cable, even though there are 2 ports. This is an LC to LC OM3 duplex multimode fiber optic cable. The LC refers to the style of end termination that's on it. The duplex means it's actually 2 cables side by side, one for each direction of communication. And the OM3 and multimode refer to what kind of cable it is. There's also OM4 and OM5, which should work just as well. Likewise, a single mode cable should work. OM3 and multimode are probably going to be somewhat cheaper though. I think I got this one for about $5 new. They aren't really that expensive. There's another advantage for fiber channel drives, and that's because a comparable SAS cable would be in the neighborhood of about 20 or 30 bucks. The other nice thing about fiber optic cables is they come in any length. You can literally buy a 100-meter long cable for like 50 bucks. For my American viewers, that's about as long as a football field. And now that I've successfully annoyed everybody, let's talk about the last piece of hardware that you're going to need. Well, that would be the tapes. Now, just like drives, tapes come in LTO 1 through 10. Here's a chart I found on Wikipedia that compares their capabilities. You might think that it would make sense to get tapes that are the same LTO generation as the drive you bought, and indeed that is my recommendation. There is some measure of backwards compatibility though. Every generation except for 10 can read and write tapes from the previous generation, and 3 through 7 can read but not write 2 generations back. This could be something good to keep in mind if you manage to score a good deal on a bulk lot of wrong generation tapes, for example. But all other things being equal, it's probably best to get the same generation. I don't have any recommendation on the brand. Several companies made tapes for each generation and they're all compatible. You don't need to worry about buying only HP tapes if you have an HP drive, for example. I definitely recommend buying the tapes secondhand too for substantial cost savings. It does take some patience, but I found a couple of lots of 10 LTO6 tapes for $100 to $150. There's one more tape that you're going to need, and that is a cleaning tape. Over time, dust or other contaminants from the environment, or even from the tapes themselves, might build up on the tape head. And these slow down the read and the write operations, and they can damage the equipment. Cleaning tape is a special tape that's designed to remove these contaminants when it's run. Unlike data tapes, a cleaning tape isn't generation specific. You can use any brand or generation of cleaning tape with your drive, and it should work just fine. And that's everything you need. Okay, so you might have wondered something, especially if you're familiar with SAS and fiber channel, which is that those are communication channels. Unlike USB, only data can flow through those, not power. So how are we going to power the drive? Well, they do sell tape drive enclosures for standalone drives, and those have a wall plug on them. I don't know about how or whether those work, although maybe someone in the comments section will be kind enough to share their experience. No, I chose to address this point by modding my tape drive. Don't worry, it's very simple. To start, we'll need to take these screws out and open up the enclosure, and would you look at that, it's a normal Molex power connector. Now that's definitely very promising. I'll go ahead and unplug all the other cables so that we can just pull the back off entirely. And this is what it looks like. You see that green PCB? That is what the drive would use to communicate with the tape library it's installed in, if I had one. I don't though, so let's take it out. And I'm also going to be taking out that fan and replacing it with another one that connects with this Molex connector cable that I have. You can skip this step if you already have an appropriate cable that can hook up to the existing fan, but I definitely don't recommend running one of these drives without a fan. Usually when manufacturers put stuff like that in there, there's a reason for it, and I would not risk a hundreds of dollars tape drive cheaping out on a tens of dollars fan. Speaking of cheaping out, yeah, I just ran the Molex cable right out the drive into my computer's power supply. Maybe one day I'll 3D print a bracket so I can panel mount a Molex plug, which would be a really nice touch. But anyway, now we're ready to hook this bad boy up and see what it can do. I just installed the fiber channel card in a spare X8 PCIe slot, and then I plugged the fiber cable that I had into it. Other end goes right into the fiber plug on the back of the tape drive. You can use either one, it doesn't make a difference. Now, before we get started with the tapes, we are going to need to install some software. You're probably going to need a driver for the fiber channel card and a driver for the tape. I'll leave a link in the description to the website where I downloaded mine from. I did have to try a couple of times to get a working driver for the fiber channel card. Not sure whether that was a skill issue on my part or if the company was just being really difficult. After everything's installed, here's what my device manager looked like. You can see that the PCIe card and the tape drive both appear here ready to use. Now there's one last piece of software I recommend before we actually start writing data to the tapes, and that's an LTFS. That stands for Linear Tape File System. Now see, a tape drive does not work like a normal hard drive that you're probably used to. The L in LTO stands for linear, which refers to the fact that tape drives do not support random access. If you want to read from one specific spot on the tape, you have to advance the tape until that specific spot is in front of the read head. Same thing goes for writing. You can't write to an arbitrary sector on the tape. You can only append to the very end. What the LTFS does is interface between the operating system and the tape drive, making the tape drive appear and function sort of like a normal hard drive would. LTFSs are only supported on LTO generation 5 and later, which is the reason that I recommended getting one at least that new earlier. LTO 4 and below would still work, but writing files to them requires command line tools or other software, which adds complexity. With an LTFS, you can copy and paste files to the tape just the same as if it were a normal hard drive. You can even delete files, although that's kind of pointless. It doesn't actually delete anything. It just tells the file system there's nothing at that spot of the tape anymore. You don't get the space back the way you could for a normal drive. The only way to actually delete something from a tape is to format the tape, which clears everything. Now, this is one nice feature that makes the tapes great for archival purposes. The data on a tape cannot be compromised electronically. Someone would need to physically access the tape in order to tamper with the data on it. Now, there are different LTFSs that you can download, but I just used HP's one. Okay, now with all of that set, we're finally ready to read and write some data to the tape. And I'll just go through that process step by step to show you what it looks like. Step 1, We're going to open up that LTFS and hopefully we see the tape drive in that top drop-down menu. It's labeled Select a Tape Drive. You can fill in an alias if you want and then pick a drive letter and then click Create Mapping. Okay, great. So you can see the button change to say Remove Mapping. That means it works. Don't worry about that preparing to mount point. I'm not really sure what that's for. I just proceeded to the next step, even though that does kind of make it look like I should be waiting for something. Now let's load a tape in. We'll start by getting a tape out of its protective plastic box and inserting it into the drive. You don't want to insert it all the way, just place it in like this, like you see here, and then we'll go to the LTFS and click on Cartridge Utilities and then Load. And as you can see, the drive loaded in the tape just like that. Now, the next step is to format the tape, which erases all the data that might have previously been on there and sets it up for me to write my own data. Obviously, you would skip this step if you already had data on the tape and you wanted to write more. We'll see a dialog box where we can enter in a name and a number. Now the number is from these barcodes that you might have seen on the tapes. Automated tape libraries use these barcodes to automatically load the correct tape into the device. I'm not doing anything like that, but they are nice for labeling purposes so that you can look up on a table what each tape has on it rather than having to load them in individually and check. For the name, I've determined that I'm going to need 3 tapes to hold all my Judging for the Win videos, so here we are, and we're going to click through the rest of the formatting wizard. And you should see the tape with the name that you chose on Windows Explorer. In order to write to the tape, I'll just go to the File Explorer and we'll see that my tape shows up with the name and the drive letter that I assigned to it during formatting. Because I'm using an LTFS, I can just copy and paste my files right in here. The write speed isn't super fast. Supposedly these drives can write 160 megabytes per second. I never saw anything close to that. More representative would be like 40 to 60. I'm not sure if the bottleneck is in the software or my network or the fiber channel or the drive or the tapes or maybe something else I'm not thinking about. And speaking about not meeting advertised specs, let's talk about capacity. You see that 6.25 terabyte claim? Yeah, that's total bunk. You won't get anywhere near that. This number refers to how much data that you can get onto the tape after compressing it. Maybe if you had a 6.25 terabyte uncompressed database or text file, the LTFS could maybe compress that down to 2.5 terabytes, which is what the tape can actually physically hold. But for my application, most modern video file formats heavily compress the data already, so any gains from the tape software compressing the file after that is rather unlikely. And I said that 2.5 terabytes is what the tape can actually hold. It's so-called native capacity, but in practice I was never able to get that either. I had write operations fail when I tried to transfer as little as 1.9 terabytes. I'm not sure whether this is because I bought the tapes secondhand and their capacity degraded, or if it's overhead from the LTFS I'm using, or maybe it's one of those things like how marketers are allowed to describe a 931 gigabyte SSD as being 1 terabyte. In any case, I would not recommend writing the full advertised capacity to your drive at once. In my use, I would write only about 1.7 terabytes at a time, maybe 1.8 if I was feeling lucky, and after that finished, I would check how much storage the tape said that it had remaining and go from there. Once you're done writing, you can eject the tape from the drive by going back into the LTFS and hitting the eject button. This doesn't happen instantaneously though. The software will always be kind to rewind the tape all the way back to the beginning so that it's ready to use the next time. So you need to be a little bit patient for the tape to actually get ejected. Now, if you want to read data from the tape, the process is very similar. You insert the tape into the drive just like before, and then you navigate to the tape drive on the File Explorer and you find the files that you want and copy them over to wherever you want on your computer. Directories and subdirectories will appear and function as normal according to whatever you set up when you wrote the data there. Do not try to stream any media directly off the tape though, because this functionality is probably not supported in the LTFS. But if you want an archival backup solution, the limitation that you can only read data instead of streaming it in real time is perfectly acceptable. There's one last thing that I wanted to show you about the drive, which is how to use the cleaning tape. I mentioned this earlier. This is dead simple too. Just insert the cleaning tape into the drive. Because of the RFID tag in the cleaning tape, the drive knows that it's a cleaning tape and not a data tape, and it starts a cleaning cycle automatically, ejecting the tape automatically after it's finished. Like I said, easy. The drive will probably have a light or other indicator that lets you know when to run a cleaning cycle. That light should go off after you run one. If it doesn't, it probably means you need to get a new cleaning tape. They're only rated for about 20 to 50 cycles before they stop working. Excessive cleaning can also introduce extra wear in the tape heads, so the best practice is to keep the cleaning tape in the box unless the drive calls for it. Which brings us to the last topic that I wanted to cover today, tape storage. If you look at the tape packaging, there will probably be some instructions about how to store them. The normal stuff about avoiding extremes in temperature or humidity, and of course you shouldn't expose magnetic tape to strong magnetic fields. There are companies that make purpose-built cases to store or transport tapes in, but these are honestly not really suitable for hobbyist use unless you're a sucker who hates money. If you just need somewhere to put them, you can get a plastic storage tote for a fraction of the price, and I reckon it would do just about as good of a job for most people. I've seen some instructions that say to store the tapes vertically, and every purpose-built case that I've ever seen is designed that way, but on the other hand, every tape library I've ever seen stores them horizontally, so it's hard for me to say that there's much of a difference. And that pretty much covers it. That is the story of how the entire Judging for the Win archive is serenely chilling out in the basement of an undisclosed house somewhere, where it will hopefully remain without ever being needed. If you're interested in getting into tape as a backup or archival solution, I hope that this video was useful to you. And if you have any questions, leave a comment and I'll do my best to get to you. But that's all I have for you today. Join me again next time for another... Whoa! You know, every year on April Fool's Day, I make one of these secret layer videos as a fun way to explore how things might be different if I had pursued some of my other hobbies or interests in this channel. And I always get a lot of comments praising me for my commitment to the bit. There is no bit. This is an educational channel, and I make videos not for fame or money, but because I want to produce valuable content that helps people, even on days specifically dedicated to goofing around. Now, if you'd like to cast a digital vote in favor of high-effort content that seems to unfortunately be getting more and more rare these days, I would of course appreciate a like or subscribe, but if you're new here, you should know that my normal videos are on a different topic entirely. And for my regular viewers who have stuck through it this long, I hope that you enjoyed getting to see a different side of me today. But that's all I have for you today. How did you do? Huh. Am I the only one who's feeling some serious deja vu right now?